In this session, we get to look at the inverse of a function. Now, speaking of an inverse of a function, it is another way of saying the reverse of a function, and it is denoted by that power -1. We know that functions can be labeled as f, g, h, or any letter. The inverse of a function is denoted by that power -1. For example, if the function is labeled g, the inverse of the function will be g to the power -1. If the function is labeled h, the inverse of that function will be h to the power -1. Now, of course, for a function to have an inverse, it's supposed to be satisfying a certain relation. And the property of this relation is such that that very function, and if that very function is made a composite of its inverse, it is supposed to be equal to this relation, and all that is supposed to be equal to x. So it means that if you're having two functions, and one function is f of x and the other is the inverse, or the inverse of that very function, then for that to be true, those two functions are supposed to satisfy this relation. And from earlier on, this simply means that these two are composite functions, not multiplication. To illustrate that further, we have this function here. F of x is going to be equal to 4x plus 2. The question is asking that if f of x is equal to 4x plus 2, then is the inverse of this same function given as x minus 2 over 4? We need to prove that this is true. Of course, for us to prove whether this function is indeed an inverse of that, we are going to use this relation. We are going to use this relation and see if we do this, it's going to equal to x. Then we are going to work out this as well and see if it is equal to x. And if this relation is fully satisfied, then we can conclude and say that yes, it's indeed true that this function is the inverse of the other. So we get started with the working. So f of x composite, its inverse, this is going to be this is interpreted as that the function where the input is its inverse. So we know that f of x definitely is 4x plus 2, so this is going to be 4 times x. Now in the place of x, if this is f of x, if f of x is given as 4x plus 2, so it means that in the place of x we are going to put the inverse. This is what we are representing here, that so where there is x, we are going to put the inverse. So in this case we are going to put f times x minus 2, divide that by 4 plus 2. Of course, from here this 4 is going to cancel out with that 4, and we are going to remain with x minus 2 plus 2, and we shall end up with x. So that's the first bit. We have been trying to verify this part of the relation here. So we are going to go ahead and do the same thing, but the reverse way, in this form. So we are going to do a reverse of this. So the composite function of those two, this is interpreted as the inverse where the input is going to be f of x. And this is going to be given by, of course, the inverse function in this case is x minus 2 over 4. So if f of x is x minus 2 over 4 as given here, so it means in the place of x we are putting there the function f of x in the place of x. So it means in this expression where there is x, we are going to put the function f of x, 4x plus 2. So meaning that in this part, it's going to become 4x minus 2. It's what we put here, then minus 2. Divide all that by 4. So definitely this is going to become 4x minus 2 minus 2. Divide that by 4. This will become 4x minus 4 over 4. This will give us 4 into x minus 1. Divide that by 4. This is supposed to be 4x plus 2 minus 2. So definitely this is going to be 4x plus 2 minus 2. And this is plus 2 minus 2. This is giving us 0. So it means this is going to become 4x plus 0. That is plus 0. And this ends up being 4x over 4. This is out. So 4x over 4, the 4's will cancel out and you remain with the value of x being that. So from here you notice one thing. You notice that when we make this a composite function of that in this expression, as exhibited here, we ended up with our final answer being x. Likewise, when we did the second step here, which is this and that, you found that our final answer was x, which is still satisfying this. So if we are to go back to the question is asking that if this function f of x is given by 4x plus 2, then is this function its inverse? From our workings here, the answer is yes. So we will conclude by saying that yes, it's the inverse. If the function f is given by these ordered pairs, now find the inverse of this f, this relation f. So of course the inverse here is going to be this, the value of x, that's y, this is the value of x, that's y, this is the value of x, and that's the value of y. And we said that the other way of finding, of calling the inverse of a function is more like the reverse of the function. So it means the ordered pairs therefore are going to become, this is 1, 2. So the reverse of this is definitely 2, 1. Then this is 2, 3. The reverse of this is 3, 2. Then this is 3, 2. The reverse of this is 2, 3. And definitely this is now the inverse of that. This is our answer. Let's say we are having a point 3, 1 right there. A point 3, 1. The inverse of this function is going to be the reverse of this, which will be 1, 3. That is 1, 3. So we are having this point right there and another right here. If I may use another this red point there and there, you realize that these points are on either side of this straight line. So this brings us to the conclusion that the graph of an inverse function is a reflection of the graph about the line y is equal to x. So meaning that if you're having an inverse function this side, if you're having a function this side of the line, the inverse function is a reflection of this function along this line. So it means that it will be reflected in this part of the graph. So the graph we are seeing right there is just another illustration of what I've been talking about. This is the graph of the line y is equal to x. So if we are having this quadratic function is to be reflected along that line. Of course, if this quadratic function is reflected along that line, this is the inverse of that quadratic function. And you realize that the inverse of the quadratic function upon reflection in this along this line is giving us a relation. This is yet another example. This is the line y is equal to x. We are having this function, it's a straight line, and the inverse of this function, like we had said, is a reflection in this line y is equal to x. So the inverse of this function is this line reflected through y is equal to x. And in this case, the inverse of the function is also a function. Now that we've seen that we can get the reflection of the function or a relation by simply reflecting it in the line y is equal to x, how then can we find the inverse of the function algebraically? So in these few next examples, we are just going to show how we can algebraically, or by calculation, we can get the inverse of a function. In our question right here, we are having, if the function f where x is the input is given by 5x plus 4, find the inverse of that function f. So finding the inverse of that function f, we get started off by first of all acknowledging this f of x. Let's call this f of x y. So it's going to become y is going to be equal to 5x plus 4. So now we want to find the inverse of this function. What we do is that we are going to make x the subject of this formula. When we make x the subject of this formula, and then we flip the two. Remember, we said that the inverse of a function is more like the reverse of a function. So if it's the reverse of the function, it means that x is going to become y and y is going to become x. And that's it. So let's start it off this way. So we're going to first make x the subject of the formula. And so this means this is going to become, we flip 4 comes this side, this becomes y, minus 4 is going to be equal to 5x. So when we divide both sides by 5, we end up with our value of x being equal to y minus 4 over 5. So since this is, we are making it, this is the inverse, is more like we are trying to flip it or find the reverse. It means that we make this value of x becomes back y and this value of y becomes x. So it means in our next step we shall just say that y therefore is going to be equal to x minus 4 over 5, and therefore we shall say that the inverse of this function f, the inverse of the function where x is the input, is equal to x minus 4 over 5. So this is how we find the inverse of this function algebraically. This is the same way you would go and plot this on a graph and then you reflect this function in the line y is equal to x. You would still end up with a function of this nature. So we have this one too. We have f of x is going to be equal to x squared. What is the inverse? Again, let's call this y. Y is going to be equal to x squared. So our task is to make x the subject of the formula. So making x the subject of the formula, we eliminate this square. It becomes the square root of y is going to be equal to x. Therefore, here x is going to be the square root of y. So what we do is that we make x become y, we make x y and y x, we flip them. So it means that y is going to be equal to the square root of x. Therefore, the inverse is square root of x, like that. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.